All right, now that you have the background knowledge, let's take a look at what actually graphing a logarithmic graph would look like, especially with some transformations. So we have y equals log base 2 of x minus 4 minus 1. I think the easiest way to do this is to actually start with just our base function, which is just y equals log base 2 of x. Now when you're doing this, it might be helpful to actually turn this into a exponential form. So like 2 to the power of y is equal to x. Because when I'm going to go graph this, what I'm going to think is 2 to the power of what is equal to 1. Because this is our equal sign and our x is what we're actually going to be looking at first. So when x is 1, so we're looking at 2 to the power of what is equal to 1. And that's the same here. 2 to the power of what is equal to 1? Well, 2 to the power of 0. So our height then would be 0. So then we go to the next x. Okay, so 2 to the power of what would get me 2? Well, 2 to the power of 1. Okay, moving on to the next one then. Now, we can't do all of the x's. We're going to do the ones that we know. So like 2 to the power of what gets me 3? I don't know. But I do know that 2 to the power of something equals 4. Well, that's 2 squared. So we have our x is 4, and then we get squared. And I also know what 8 is. So then 2 to the power of what is 8? Well, our what is our, so we have 8 comma 3 then. So we're getting our graph this way. Now as we go into negative heights, so 2 to the power of what gets me 1/2. I know what 1/2 is, and that's going to be negative 1. And I know negative 2 will be 1/4, and that pattern will continue on. So now we kind of have like our parent function, and we should label this y equals log base 2 of x. Now we can deal with the transformations on it. So we have two translations. We have a horizontal translation of 4 right, and then we have a vertical translation of 1 down. So I'm going to take each of my key points here, and I'm going to shift them down 1 and then right 4. So 1 down, right 4. 1, 2, 3, 4. 1 down, over 4. And then 1 down, over 4. 2, 3, 4. So that's as much of that part of the graph as we can graph. And then same thing here. 1 down, over 4. 1 down, over 4. Now this has become our new asymptote. So we could label that. So we've got this asymptote here. The more explicit you make it, the better, especially when you've got a diploma and you have somebody who's marking this that doesn't know you and they're looking to take away marks. So make it very clear that that does not cross the line, and we should label that as well. That is our log base of 2 x minus 4 minus 1. Now some of the part B we have already done. We already know what the equation of the asymptote is. I have it labeled here. It occurs at x equals 4. Our domain, so our x values are based on that asymptote. We can't have less than 4, and it goes all the way to infinity. For our range, we go from negative infinity, so it keeps on going forever, all the way to positive infinity. Now, we don't have a y-intercept, so there's none of that, but we do have an x-intercept. And so our x-int occurs at x equals 6. Let's look at one more really similar example. So we're going to graph y equals 2 log base 3 of negative x plus 1. We'll start with the same strategy. We're going to actually graph the parent function first. So that's y equals log base 3 of x. Now it might be helpful for you to put this in exponential form. So 3 to the power of y is equal to x. And when I'm doing this, I'm thinking then 3 to the power of what gets me, well, one that I can do is 1. You can see it's already sketched there. And then I can't do every one. So I don't know 3 to the power of what gets me 2. I don't know that. But I do know that 3 to the power of what gets me 3. And that means my exponent would have to be 1. So I've got a height of 1. And then 3 to the power of what? Well, the next one I know is actually 9, which is a little bit off the graph. So 3 to the power of what gets me 9 is 2. So I've got a height of 2. Then we can start going the other direction. So as we get into a negative height. So I know when I have a negative 1/3, or negative 1, I get 1/3. And then I'm going to get 1/9 when I have a negative 2 exponent. And that's as far as I'm going to kind of graph, because we've got that asymptote there. We don't want to make it look like it's crossing that. So there's my kind of sketch. We should label this. We don't want someone to think that we're not sure what we're supposed to be graphing here. Okay, the second part then, to do the transformations. Now there is one extra step in here. This is a negative x, which we're not allowed to have just that negative right next to the x. We have to factor that negative out. So it becomes 2 log base 3, and then we factor out that negative, so it becomes x minus 1. So now when I look at my transformations, I have a vertical stretch by a factor of 2. So it's going to get 2 times bigger. I have a horizontal translation. So that's showing up right here. Now I know it says -1, but it's actually going to be a +1, so it's 1 right. And then we have this negative here. And so that's going to be a reflection over the y-axis. Now you could do these all at once, or you could maybe do a couple at the same time. I don't think that these are so complicated that we can't do this in one try. So I'm just going to make a little star of things that affect my x. So my vertical stretch, or sorry, my x is my horizontal stretch, and then I'm going to have my reflection. That's what's affecting the x. This reflection happens first, then this translation is going to happen. So you got to remember that order. The vertical stretch can happen at the same time as the reflection. The order doesn't matter too much there. All right, so let's do each point. Let's start with this nice easy point. What was our intercept? So 2 times the height leaves me at 0 still. Then I'm going to reflect it across the y-axis and then move it 1 right. Okay, going on to the next point. So this was at a height of 2. So I'm going to multiply it by 2, so I get a height of 2. Then I'm going to reflect that across the axis and then move it 1 right. This point is going to possibly be on the graph now because of the shift right. So we have a height of 2, so that's going to become a height of 4. Then I'm going to reflect it across the axis, and then I'm going to move it 1 right. So yes, it's just barely on the graph now, which is good. And then looking at these negative heights. So I'm going to double the height. So we end up there, reflect across the axis, and then move it 1 right. And it'll be the same thing with this point. So we're going to double the height, so it goes to 4, -4. And then we're going to reflect it, and then move it 1 to the right. And so now we should have an asymptote at x equals 1. So we're going to make that very clear. So and we use dash lines for that. You'll have a ruler. That's x equals 1. Make sure that we label this. So this is our y equals 2 log 3 negative x plus 1. I'm going to put the original equation just to make it very clear that I know what I'm doing. And that's it for that question then. Now for the b part, we have, well, what's the equation of the asymptote? Well, we actually already have that. That's at x equals 1. Next is our domain and range. So I'll do that down here. So my domain of this, again, it's all about what my asymptote is. The difference this time though is because of that reflection, we're actually getting from negative infinity. And it goes all the way to the asymptote at 1, but it doesn't actually ever hit the asymptote, so it's not included as part of the set. And then for our range, as always, we are having from negative infinity to infinity. Finally, our x and y intercepts. So our x-intercept is actually the same as our y-intercept. They both occur at 0. So our x-intercept is at x equals 0, and our y-intercept is at y equals 0.